Good afternoon to one and all. This is Dr. K. Pushpa Rani, Associate Professor, Department of CSC. In this video we are going to discuss about trees and what are the properties of trees and what is meant by spanning tree. So generally, what is the tree structure? So in the case of general view of tree is these are the leaves, this is a root, and these are the branches. This is the general view of tree. Then coming to the computer scientist point of view, the tree will be in the reverse order. That means root is on the top position. These are called that means the nodes which are present at the middle. That is a middle. That is called as the leaf nodes. The nodes which are present, these are called as a branches. This is the computer scientist point of view. So this is the general view of tree structure. This is the computer scientist point of view tree structure. That is the first node is called as root node. These are called as leaves, that is also called as branches, and it is not called as a nodes. This is the computer scientist point of view. We can represent the tree like this. Then coming to the definition of tree. A tree is a non-linear data structure. That means we have to store the data in the linear order. There is no particular order. We have to store the data in the form of non-linear manner, which consisting of all the nodes are arranged in the form of hierarchical structure. So we can say that how can we say that if it is a tree should satisfy the following properties. If the following properties are not satisfied, then we can say that it is a tree. First condition is it has only one designated node. That means only one node can be presented on the top level. That is called as a root node. For the root node has no parent. Root node has no parent. Second one is every node except the root node has exactly one parent. For root node there is no parent. For the remaining nodes there is a one parent. At least one parent should be present for the remaining nodes. Third one is a node may have 0 or more children. So some nodes may consisting of 0 children, or some nodes may does not consisting of any children, even though it is a property of tree. Next, there is a unique directed path. There is a path should be present between the parent to child. So then that is the designated path should be present. So consider this example. How can it is a tree or it is not a tree? One designated parent, that is called as root. Every node having one designated parent. 3 parent is 5, 2 parent is 5, 2. So 4 parent, 1 parent, 6 parent is 2. That is second condition. So a node may have 0. That means 3. 0 children. And 2, 3 children. There is a path is present. In a directed path is present to reach from the root node to 4. How to reach from 4 to 2? 1, 5 to 2, 2 to 4. Next. So there is another example 5. So to reach 4, there are 2 paths, but it is not correct. Only unique directed path should be present. So fourth condition is not satisfied, so it is not a tree. Next, coming to this example, so 1 to 6 is not connected. So 1 and then 6. 6 parent is 1. 1 is not connected to any way. So there is no path to reach from 5 to 6. We can reach from 5 to 2. After that, if it is connected to 1 to 6, then it is a designated path. But 1, 6 are separated, it is not a tree. So tree is a non-linear data structure which consisting of the nodes must be arranged in the form of hierarchical structure. So coming to the spanning tree. What is the definition of spanning tree? A spanning tree is a connected undirected graph. What is the difference between tree and graph? Tree is represented in the form of linear structure, but whereas graph is represented in the form of closed path. So tree consisting of there is no closed path for tree, but there is a closed path is present in the graph. But in the case of spanning tree, we should not include all the edges and all the vertices. We have to include only minimal number of edges in the spanning tree. So one graph we have to draw any number of spanning trees, any number of spanning tree. This is the graph For this graph, we need to draw A2. That means this is the graph, but here F to B, no H, F to D, no H, B to E, no H, D to E, no H. So even though it is a spanning tree, but minimal number of edges are included. We can include any number of edges, but there is no closed path for the spanning tree. So we need to draw the spanning tree for the following graph. For one graph, we have to draw any number of spanning trees. One spanning tree is A to B, then A to C, C to D, and A to D. That is one spanning tree. That is also one spanning tree. Next, A to B, A, B, D, C. This is also one spanning tree. Next, A, C, D, B. This is also one spanning tree. So for one graph, we have to draw any number of spanning trees. Any number of spanning tree. But minimal number of edges are removed. A minimum number of, but all the vertices are present, but not all the edges. For this single graph, we can draw any number of spanning trees. Next, draw the spanning tree for the following graph. So we have to take A, B, C here. A to B. This is one spanning tree. This is also one spanning tree. So this is all written. Next, we can draw like this. C to D, D, C, E. This is also one spanning. So for one graph, you have to draw any number of spanning trees, but it contains minimal number of edges. It contains minimal number of edges. So what we have discussed, what is meant by tree, what are the properties of tree. So what is the definition of spanning tree? One, we already discussed some examples on spanning trees. Thank you.